All right, so I'm going to talk about testing machine learning models. And so I'm gonna be flipping back and forth between the keynote full view and the chat. And so if you if it takes a while for me to get to your questions, then just hold on, because when I'm in full view in keynote, it's not going to let me look at the screen here. So I guess the first thing I want to cover is just why talk about this at all. And so I think the one thing that I've observed in talking to a lot of folks who work on production machine learning is that good, robust practices around testing machine learning models are still pretty uncommon. And I think that there's a couple of reasons for this. And to illustrate this, I want to talk a little bit about some cultural failure modes that I've noticed in machine learning teams. And so the one on the left is what I would term the cowboy machine learning engineer. And so this is an organizational pattern that I see a lot where machine learning engineers kind of, the way that they treat production is they take their model, they get a good validation score on that model, and then they train, fire, and forget. They launch it into production, maybe wrap it in a Flask app, and just assume that it's going to continue working there. And so so these folks are kind of trying to move quickly. Maybe they're not really trained as software engineers, and so they're putting a lot of stuff into production without really testing it. The other really common failure mode I see in ML teams is what I would call the ivory tower data scientists. And so this is the folks on the right here. And these folks have the attitude of like, okay, my job is to produce a trained model for you, and like when my trained model is done and validation score is good, then that means that I'm done, and I hand it off to some other team that is responsible for handling production. And in this case, oftentimes you have a DevOps team or a production team that are really well trained as software engineers, and so they're going to make sure that you have good unit tests and that you have good production monitoring. But oftentimes they don't really know how to test models statistically and understand the data that's coming through them either. And so in either case, you end up with sort of poor testing. And the other question you might ask is like, how bad is this really? Maybe it's okay just not really to test machine learning models too much. But I think in reality, really bad things can go wrong. So if you just look at the validation score of your model, and you don't understand how that validation score breaks down for different subsets of your data, you can end up with things like algorithmic bias, like models that exhibit racist behavior or other concerning behavior. Even if your model performs really well right now, that doesn't really tell you anything about how it's going to perform later. For many of us, machine learning models don't operate in isolation. They operate in the context of some larger data infrastructure, right? And so bugs in other parts of your data infrastructure can seep into your machine learning code, and they can produce problems for you down the road if you're not tracking them. Even if you don't actually change the code at all, you can still get your model performance to fall off because of data drift. The distribution of data produced by your users changes over time in a lot of cases, and that can cause your model performance to fail. And then, even if you don't have data drift, you can still have users that intentionally try to take advantage of your system and by injecting malicious inputs to your model. And so this can also cause problems. And then finally, even absent all of this, a lot of machine learning use cases operate in the long tail. So you're working on self-driving cars or language or anything that has huge data distributions, then a lot of times you're in the situation where it's relatively easy to get to up to 60% or 70% coverage of your data in your training set, but there's lots and lots of data that may not be covered by your training set, and it can be really hard to detect these things without proper testing. Okay, I'm going to flip back to the chat here. Okay, good. So what I want to cover in the rest of this talk is, first I want to talk about what are the different types of tests that you can use to correct this, right? So to properly test your machine learning code. Then I'm going to talk a little bit about how to operationalize those tests, right? So how to actually put this type of testing into practice. And then I'm going to touch on a few what I see to be kind of open questions that there isn't really a good best practice for in the machine learning testing world. So starting with types of tests, the first thing I'll talk about is I'll sort of give the context of what a typical production ML system looks like, and then I'll situate the tests in that production system. So kind of the core of your production system is a prediction module. And the prediction module's job is to take some input data, process it, build your neural network or your model with the trained weights, and then make predictions. But that's not the entire machine learning system, right? So you have also a training system that is used to create that prediction system. So the training system combines data and code in order to produce model weights. And then finally, you need some way of serving that prediction system. And so that's responsible for actually running the prediction system and scaling it up and down to meet demand. And so the prediction system, you can think of it as this is the module that takes your training and validation data as input. And the serving system is the system that takes production data as input. So what are the different types of tests that we can associate with this system? Well, with our training system, it's important to test this. And tests of the training system are I would term infrastructure tests. So there's different types of infrastructure tests. A really important type is to be able to test to make sure that for all of the different models that you want to be able to train in your machine learning infrastructure, just make sure that they can, if you train them for a really short period of time, there's no obvious bugs, and they seem to be starting to make progress. These I'm terming single batch tests, and these you can run very frequently on every commit, or even more frequently than that if you're playing around with stuff and want to make sure that you're not breaking any historical models. You can also have longer running tests of your machine learning infrastructure, so you can do full training runs. And training runs are slow, so you typically can't do these on every single commit, but you can run these like every single night or every week or something like that. And the purpose here, again, is really to catch regressions in your code and your infrastructure. And just to share a kind of a quick story on this, when I was working on robotic stuff at OpenAI, we had multiple occasions when we were moving through a progression of tasks, increasing difficulty, more and more complex robots and objects. And there were a few times where we came back, we had solved the task, we looked at it again a month later, and we found that our system could actually no longer train a model to solve that task, even though it was working well on what we thought were harder tasks. And so that was the thing that that forced us to really make a decision to implement infrastructure tests. The next type of tests that I want to talk about are called functionality tests. And so these are really just testing your prediction system on a few key examples. And these are designed to run fast so that you can run them in development. And so as you're training new versions of your model, as you're playing around with your code base, you can just run these frequently to catch regressions in the code that would cause a trained model not to be able to perform as well on a small set of examples where how well it should. So these are tests that run on a very small number of key examples. You also want to run tests on a larger number of examples. So these are validation tests. And the goal here is really to catch regressions to the model itself. So if you train a new model, this will help you determine whether that model's performance is really better than the last version of your model. And it's important to note here that you might think that this is just your validation score, but this is a lot more than just your validation score. And I'll talk a little bit about what else you might want to be covering there. Then as you're moving your prediction system into production, the next thing that you'll want to test is making sure that prediction system is going to perform well in production before you start serving it to all of your users. And so these are deployment tests. And the goal here is to catch bugs that only show up in production before they affect users. And I'll talk about some strategies to do that. And then finally, tests of the live serving system itself. And this is what we could term monitoring. So this covers traditional infrastructure monitoring stuff, getting alerts about downtime, errors, but also more statistical monitoring. So catching distribution shifts, flagging outliers, and detecting data that doesn't really seem to match the data that the model was trained on. Okay, I'll pause here to see if there are any questions so far. All right, if no questions, then I'll just keep going. So I'm going to zoom into validation tests and talk, I mentioned that this is not just your validation score. And so I want to talk a little bit about what else you might want to cover in this bucket. So the first difference between validation tests and your validation score is that you almost always want to be evaluating multiple metrics. So not just your loss, not just a single number, but everything that you really care about when you're evaluating your model's performance. So, simple example is you're not just looking at your loss, you're also looking at things like precision and recall. But for some problems, you might have tens or dozens of metrics that you want to look at. Another difference between looking at your validation score and doing validation testing is that you almost always want to aggregate that score, not just on your entire validation set, but on multiple slices of that validation set as well. And so what kinds of slices might you want to evaluate on? Well, for one thing, you might want to look at how your performance differs for your important users. Right? So if your company has 5 or 6 users that correspond to a large percentage of your traffic, then you'll want to make sure that your model performs well for those users, as well as performing well in aggregate. This is also where you can look at things that you don't want to bias against, right? So if you're worried about your model potentially doing some form of discrimination, discriminating by gender, discriminating by race, or anything else, then you can create data slices for the classes that you don't want to bias against, and then evaluate your model's performance metrics against each of those classes. So you can determine whether performance is degraded on those classes. You can also use data slices to pick cohorts or edge cases that have had poor performance in the past. So if you're working on self-driving cars, for example, and in an earlier version of your model, you notice that performance was bad at night, then you might want to create a data slice that corresponds to night driving or night images. And then every time you push a new model, make sure that you're not only performing better on average, but you're also performing at least as well on night scenes. If you're in a situation where your predictions are safety critical, or they're going to be shown directly to users, it's people are actually going to be judging the results of your predictions directly, then you can consider doing qualitative error analysis. So qualitative error analysis is really manually looking at the predictions that your model makes, or the mistakes that it makes on your data set. And the types of things that you're looking for here are really like, okay, just sense checking this prediction. Does it seem like my model is doing something reasonable, even if it's making a mistake? Can I understand the failure modes that my model is making and try to improve them? And there are tools that you can use to help make this process easier. The most commonly used one that I've seen is called Google's What If tool. And this is used for analyzing slices of your data, servicing slices that have poor performance, and then zooming into those data points. So in some machine learning models, your model actually affects the state of the world when you're making predictions, right? So if your model is running behind a self-driving car, then as that model makes decisions, the car will change position in the world. And so that'll affect the data that it gets downstream. Similarly, if your model is making recommendations to users, those recommendations can actually change the behavior of users. And so the data that the model sees in the future will depend on the predictions that it makes in the past. And so if your model has those characteristics, then one thing that you should consider doing is using simulation as part of your testing suite. So simulate the world and evaluate over time how your model's predictions affect its downstream performance. And then another type of validation test that's worth considering are called expectation tests. And so expectation tests are, you take a data point where you know what your model's prediction is, and then you perturb some of the inputs in a way such that you should have some reasonable expectation about what that should do to the model's performance. So for example, if you're doing sentiment analysis and you take a sentence that the model has classified as having positive sentiment, and then you take one of the words in that sentence and you make that word more positive, then you should still expect the model to give a positive sentiment score. Or if you take one of the words in the sentence that you shouldn't expect to have an effect on the model's sentiment and you change it, then the model's prediction should be unchanged. And so this is just another way of sense checking whether your model is really doing reasonable things. All right, I'm going to pause here again and check to see if there are any questions. Okay, so are there any test frameworks that you follow? I'm going to talk a little bit about this in a second, but my perception is that there's not really an equivalent of the test frameworks that we have for in software engineering, right? So there isn't really a good equivalent of test coverage for machine learning. And then there's a second question around, can you give an example of how to detect that a model prediction is bad or poor? So if you have labels, then this is easy, right? So you can just look at, you can just essentially look at your loss function on that data point. If you don't have labels, then your options are more limited, right? So you can sort of try to qualitatively sense check the predictions. You can look at something like the model's confidence, but that could be an unreliable metric. And so really what you're going to need to do is you're going to need to figure out how to get some labels for your data. And like one of the important things to figure out is how to choose the subset of data that you're going to get labels for. So at what point, if any, do you integrate machine learning explainability methods into your testing, especially if you're getting good results? That's a good question. I think the way I think about explainability is I would consider this part of the so it's a little bit problem dependent. There's some problems where explainability is useful, and there are some problems where it's less useful. So for example, in like image tasks, generally explainability doesn't really work as well, and it's not really clear how it would be useful even if it did. So if you're working on a problem where explainability is useful, then I would consider this part of your qualitative testing, right? So I might put your explainability module into the loop of your testing framework, and then just have a norm that before you push a new model to production, you look at some number of explanations, like 10 explanations of predictions, and maybe you choose those 10 based on things that you know are particularly important for the model to be able to explain, and just sense check them and make sure that those explanations are reasonable before pushing your model into production. All right, I'm going to continue from here. So the next type of tests are deployment tests. And again, the goal here is to catch bugs that only show up in production. So I think the types of deployment tests that you can do in order are offline, online consistency tests. And so this just means for a certain set of data points, make sure that the prediction that your offline model makes, so like your local TensorFlow or PyTorch model, for example, is the exact same thing as your online model, so the model that's part of your sorting system. And so this can catch bugs in translating your offline model to online. Backtesting. So this means testing your model on actual historical production data. And so this can catch bugs where, for example, you have implemented some stuff in your data pipeline that are not actually present in the production data pipeline. Hardware in the loop testing. So once you've back tested your model, if you're in a situation where you're not just doing web deployment, you're deploying to an edge device or to like a camera, for example, then one thing that's worth doing is actually testing the model on the hardware itself. And so it can be hard to test the actual performance of the model, the prediction accuracy of the model on real hardware, but you can definitely test the the performance of the model in terms of like latency and things like that to make sure that you don't have any regressions there. Then once you've tested your model on the real hardware, if that applies, then the next thing that's worth trying is putting your model in shadow mode. And so this just means deploying your model alongside your production model, but not having its predictions actually go back to your users, and just having them go back to your data science team instead. And then you can run your model in shadow mode for a certain period of time and compare how the results look between the real production model and the shadow production model. Once you're happy with how shadow mode results look, the next thing that you can do is run an A/B test. And so you can send a fraction of your traffic to your new production model and actually send those results to the users, unlike shadow mode, and then compare how those things perform. And so this can give you different results than shadow mode if your model, for example, affects users' behavior. And then finally, once your A/B test pass, then you can do a full production rollout. All right, I'm gonna cover monitoring as well, and then I'll pause for questions. So the goal of monitoring is really to catch bad production data as early as possible. So the quickest way to catch bad production data is by doing data validation. What data validation means is you have some schema, some expectations about what you think the data should look like. So it should have these features should be within these ranges. And you can validate that the data matches the schema at runtime. If you do that, then you can catch bugs really quickly, maybe even before you return a bad prediction to the user. The next thing that you can do is detect distribution drift. So if you have feature data and if you have a relatively small number of features and those features are relatively uncorrelated, then this works really well to just detect distribution drift on each feature independently. And so what you can do here is you can just visually look at histograms of the distribution of each of the features, or you can look at quantitative metrics like the KL divergence between the distributions of features. And this can, if those distributions start to change, even if you don't have ground truth performance, this can tell you that your performance is likely to be degrading. And then finally, it is really important to also capture true production performance. So if your users can tell you when you've made mistakes, so if your users can correct your predictions, or if your users are clicking on something based on your predictions, then capturing that is really important. And if you don't have that, then one thing that you can do is you can, and what you need to do is you need to make sure that a subset of your data, subset of your production data is getting labeled, so that you know how the actual accuracy of your model is evolving over time. And this is so important that you should even do this, even if it means that you need to make suboptimal predictions on some examples. So if you're doing fraud detection, for example, right? In order to know if a transaction is fraudulent, you need to let it go through. And so some of the top fraud detection teams that I've talked to will take a very, very small subset of their production data, and they'll just let it go through no matter what the model says. The examples that the model thinks should be fraudulent are actually fraudulent. But that's just to give you a sense of how important this is. All right. Since I got a late start, it looks like I'm actually more or less out of time. I'm happy to, I'm getting some extra time. Wonderful. So there's a question here around if you catch bad data before serving to the customer, do you end up not serving the prediction, or do you instead use the middle of the road prediction? I think it's a little bit use case dependent here, and it's also a little bit dependent on how confident you are that it's bad data, right? So if the data is like literally bad schema, like you're missing columns or something like that, then you should probably just throw an error, because you really shouldn't expect your model to perform well on that data, and it probably means that you either have a bug or your user is doing something bad. If you're a little bit less confident that the thing that you caught is actually an error, right? So if it's just like this data point statistically looks like an outlier, then I think it's better to just surface that as an alert to the data science team, but to still serve a prediction to the user in many cases. Yeah, I think so. There's another question around like, should you just use mean or median? I think that what should you? So maybe another way of phrasing this is, what should you fall back on if your model performance, if you catch some sort of outlier? Using a fallback model is a really good idea. You could just use mean or median. You could also use a simpler model like a regression model or something like that. So that's a good thing to consider using as well. So maybe in the remainder of my extra time, I will just talk quickly about I'll talk quickly about how to actually operationalize tests. So a few things that you need right off the bat is you need buy-in that this is a good idea. So for a lot of data science teams, this is sort of where they get stuck. You need to have a team norm around having pull requests and code review in place. If you don't have that, which a lot of data science teams don't, then it's going to be really hard to get robust testing in practice. And then you need to have an organizational norm around like, okay, this is really important, and that means that we're going to actually enforce this. We're going to enforce running tests every single time we commit new code to our repo. So the next question is, which tests should we run when? And I'll just kind of flash this up here. There's some tests that you should run frequently. There's some tests that you should run every time you push new code or you commit new code. There's some tests that should be run every night. And then there's some tests that should just be run before you're ready to promote a new model to be a production model. There's a bunch of kind of SaaS tools for managing these types of tests. I personally use GitHub Actions, but these all work pretty well. If you need more flexibility or you need GPU support, then you can use one of the more open tools like Jenkins or BuildKit. I think for monitoring, the one thing I'll say here is that for just typical like log monitoring and metrics and things like that, most of the tools, most of the cloud providers have good tools. But for data distribution monitoring, there's a few examples that are starting to pop up, but this is still an underserved need, and so you might need to build something here yourself. All right, and that's all I have time for. So I'm happy to stick around and answer questions. And thanks for coming.